Hi everyone, it's the Math Sorcerer here with Chegg. In this video, we're going to discuss trigonometric identities. Let's start with an example. We have to verify that the secant of x minus the cosine of x, all divided by secant x, is equal to sine squared of x. Let's carefully work through this solution. So when you're verifying trigonometric identities, it's usually a good idea to start by writing down the more complicated side. In this particular example, the left-hand side is the more complicated side. So we'll start by writing it down. So we have secant x minus cosine x, and it's all being divided by secant x. Now you want to look at this and think, are there any common trigonometric identities that you can use? And there's none that really come to mind. So a good general strategy is to convert everything to sines and cosines. So secant is 1 over cosine. And then we still have the minus cosine x. And all of this is being divided by secant, which is again 1 over cosine. In order to make things a little bit more clear, we're going to put parentheses in the numerator and parentheses in the denominator. Note they're already there, it's just no one actually writes them, they're just implied. Except now, because we have fractions over fractions, it's a little bit more important to indicate where the parentheses are. So now we need to figure out how to get rid of these fractions. So one trick is to multiply by cosine x over cosine x. This is the same thing as multiplying by 1 because these cancel. And so when you do this is going to cancel the 1 over cosines. Going to cancel the cosine in the bottom there. So this is equal to distributing cosine times 1 over cosine is 1, then minus, then cosine times cosine is cosine squared. You get cosine squared of x over, and on the bottom, these cosines just cancel. We get 1. This is equal to 1 minus cosine squared x. And this is equal to sine squared x via an identity. And so that is our complete verification. Something needs to be said about this last step here because it's really important to memorize that 1 minus cosine squared is equal to sine squared. So I'm going to show you how I memorize it. So if you have sine squared x plus cosine squared x, most people know that this is equal to 1. And so what you can do from this is you can get two more identities. You can solve for sine squared by subtracting cosine squared from both sides. You get sine squared x equals 1 minus cosine squared. Likewise, you can solve for cosine squared by subtracting sine squared from both sides. You get cosine squared x equals 1 minus sine squared. That's great, but then it requires memorizing it. So how do you get your mind to remember these things? I think of it like this. Sine squared is equal to 1 minus the other one squared. What's the other one? Cosine. Cosine squared is equal to 1 minus the other one squared. What's the other one? Sine. So sine squared is 1 minus the other one squared. Cosine squared is 1 minus the other one squared. And that memory trick will help you memorize these identities. Okay, let's go ahead and do another example. Verify 1 over 1 minus sine squared equals 1 plus tan squared. In this problem, you could start with either side, but let's go ahead and start with the left-hand side because I think it might be a little bit easier to explain. So we'll start by writing down the left-hand side again. So 1 over 1 minus sine squared of x. And we just saw this, right? 1 minus sine squared is the other one squared. So this is 1 over cosine squared x. Because cosine squared is 1 minus sine squared. 1 over cosine is secant, so this is going to be secant squared x. And via an identity, this is equal to 1 plus tan squared x. And that would be it. And so the identity we used here was, the main one was 1 plus tan squared. X is equal to secant squared x. So very, very useful. You could go backwards too, think about it. You could start with 1 plus tan squared. That's equal to secant squared, which is 1 over cosine squared. And cosine squared is 1 minus the other one squared. So you could have started with either side, and in theory, been able to do it with a reasonable amount of knowledge. Let's go ahead and do one more. Verify sine to the fourth of theta minus cosine to the fourth power of theta equals sine squared of theta minus cosine squared of theta. Let's go ahead and work through its solution. Let's start by using the left-hand side because it does look more complicated. So we have sine the fourth power of theta minus cosine to the fourth power of theta. And this actually factors. This is actually parentheses sine squared of theta minus cosine squared theta times, and then it's sine squared of theta plus cosine squared of theta. So it's the difference of squares formula here. So if this factorization is not obvious, let me attempt to explain it up here. Think of A as sine squared and B as cosine squared. So it's A minus B times A plus B. So A is sine squared and B is cosine squared. That's going to be A squared minus B squared. And so if your A is sine squared, when you square it, you get sine to the fourth. So yeah, very, very powerful factorization formula. So this is equal to parentheses sine squared theta minus cosine squared theta. And then sine squared plus cosine squared is 1. So this is times 1. And 1 times this is just this. So this is sine squared theta minus cosine squared theta. And that's the right-hand side. And so we're done. So just a really nice technique whenever you have the difference of things to the fourth power. So like x to the fourth minus y to the fourth, you can do the same thing, right? You could say this is x squared minus y squared times x squared plus y squared. And once you see this once or twice, it sticks with you because it's so useful, as you see here. Hopefully this video has been helpful and you've learned some math. If you feel you have, make sure to check out more videos on Chegg. Until next time, good luck and take care.